Alright, so this is your final exam review. We're going to start with problem number 1. Alright, and it is a right triangle trig problem. So we're given that side A equals 8, side B equals 5. We want to find side C, angle A, and angle B. Alright, so the easiest thing to first find is side C, of course, because you can use the Pythagorean Theorem. So it's a squared plus b squared equals c squared, or this would be 8 squared plus 5 squared equals c squared. Alright, so that's going to be 64 plus 25 equals c squared, or 89 equals c squared. And so if you take the square root of both sides of the equation, you'll have c equals the square root of 89. Now notice at the bottom there that it doesn't list the square root of 89. It has decimals, so you'll need to find the decimal and round it to 2 places. When you take the square root of 89, you're going to get approximately 9.43. Alright. And then the easiest angle to find from here would be angle B, because you have the opposite side and the adjacent side. And if you remember, the tangent of an angle measure of a right triangle is going to be opposite over adjacent, 5 over 8. So in your calculator, what you want to do is you want to say inverse tangent of 5/8. All right. And so usually on scientific calculators, and you need to make sure that your calculator's in degree mode for that, because these calculators, if you're using one, sometimes you have to get degrees, sometimes you have to get radians. So, you need to make sure that since all these answers are in degrees, that you have your calculator in degrees. You do second tangent of 5 divided by 8. All right, and if I round that to 2 decimal places, because that's what's here on the sheet for some reason, it's not 1, it's 2 decimal places, then that's going to be 32.01 degrees, because in your calculator it's 32.005, so it'd be 0.01. Now that and that's angle B. Now that we know what 2 of the angles are equal to, because remember, this is 90 degrees right here, and then that's going to be 32.01. You can say that angle A is going to be 180 minus 90 minus 32.01. All right, and if you do that in your calculator, you're going to get that angle A is equal to 57.99 degrees. All right, and then you just come down and pick the answer that has those 3. Okay. On number 2, the sine of the inverse sine of negative 0.6, as long as this number right here is between negative 1 and 1, so as long as it's between negative 1 and 1, then the answer is just going to be equal to the negative 0.6. If it's not between negative 1 and 1, it's no solution or not defined. So you can see the answer there is A. All right, on number 3, we want to know the quadrant where theta lies if sine is greater than 0. So I'm going to write my salty C chart up here. So sine is greater than 0. That means sine is positive. Sine is positive here and here. And then cosine is less than 0. That means cosine is negative. Cosine is negative where? Here and here. So whichever one you have that overlaps, whatever quadrant that overlaps in, which you can see is quadrant 2, that's where theta lies. So the answer is quadrant 2. All right, this next problem, you're going to have to use the complementary I'm sorry, yeah, what is it called? The complementary angle theorem. We can change, since this is 50 degrees right here, tangent of 50 minus cosine of 40 over cosine of 50. You want them all to be 50 degrees. So what you can do is change the numerator to the sine of 40 degrees. So then this expression right here becomes, not 40 degrees, 50 degrees, sorry. Remember, if the two angle measures of the cofunctions add up to be 90 degrees, then they're equal. The cosine of 40 is equal to the sine of 50, because 40 plus 50 is 90. All right, so this expression would become the sine of 50 degrees over the cosine of 50 degrees, which is the tangent. If you do sine over cosine of the same angle measure, it's tangent of 50 degrees. So this problem becomes tangent of 50 degrees minus tangent of 50 degrees. So as long as you have something subtracted from itself, that's always going to be equal to 0. All right. Now, number 5 is a little tougher than number 2. The inverse tangent of the tangent of 4 pi over 7. So this angle measure right here needs to be between negative pi over 2 and pi over 2. And it's not. So the way you can tell that it's not is because, remember, here's 0, here's pi over 2, here's pi. This down here is negative pi over 2, or 3 pi over 2. And then this right here again is 2 pi. So if you just look at the fraction part, 4 divided by 7, 4 divided by 7 is, let's do that in the calculator, 4 divided by 7. I get 0.57. So that's a little bit bigger than the 1/2, 0.5. So it's right here in this quadrant. So 4 pi over 7 is in the second quadrant. But remember, inverse tangent is defined between negative pi over 2 and pi over 2. So what we have to do is change it over into the quadrant that would have the same positive or negative sign as this answer in here. So since this is in the second quadrant, tangent is negative in the second quadrant. So we need to change it where it is defined into the quadrant where it would also be negative, which would be the fourth quadrant. But it's the fourth quadrant written as a negative angle measure. So remember, with inverse tangent and inverse sine, you can use the shortcut though. If you make it the angle measure in the first quadrant, then you just put a negative in front of it, and that moves it to the fourth quadrant. So basically, all we need to do is find the reference angle for this, and then put a negative in front of it, and that'll put it down here. So the reference angle chart, remember in the second quadrant, is pi minus theta. So if I want to solve for the reference angle, I say pi minus theta equals 4 pi over 7. And solve for theta. So I subtract pi from both sides. I have to get a common denominator. Since this one already has a denominator of 7, my common denominator is going to be 7. So I say 7 times negative pi, that gives me negative 7 pi. So 4 pi over 7 minus 7 pi over 7 is negative 3 pi over 7. And I had negative theta equals that. So if negative theta is equal to negative 3 pi over 7, then positive theta is equal to positive 3 pi over 7. All right? So that's the answer from the first quadrant. That's the reference angle. But we want to change it into the angle measure in the fourth quadrant, written as a negative angle measure. So the shortcut is just to put a negative in front of this. So in this quadrant, that would be negative 3 pi over 7. Now that puts the angle measure between negative pi over 2 and pi over 2. So the answer for this is negative 3 pi over 7. That one right there. That's one of the tougher problems on the test, I would think, just because you have to change it from the second quadrant to the fourth quadrant. And then to do that, you got to find the reference angle and then put a negative in front of it. At least we didn't have to do anything special other than put a negative in front of it to find the answer. All right, for these next few, or for any problem, make sure you use your formula sheet. I don't expect you to remember all of those formulas. But the next one says express the product as a sum. So if you look at your product to sum formulas, you can see that sine times sine, that's going to be the first formula under your product to sum formulas. So that's going to be equal to 1/2 times, the first angle measure is alpha, and the second angle measure is beta. So it's going to be 1/2 times the cosine of alpha minus beta. So 8 theta minus 5 theta. That's 3 theta. And then we have minus, that's important that you put a minus, the cosine of alpha plus beta. So that's the cosine of 8 theta plus 5 theta. So 8 plus 5 is 13 theta. And then we can't put those two terms together, okay? We have to leave those separate. So you can see that's going to be A. All right. On problem number 7, it says find the area of the triangle. If necessary, round the answer to 2 decimal places. So it is going to be necessary to round because of the formula that we use. Now remember, your book for some reason uses K as the variable. I mean, it doesn't matter. I usually use A, but all we need are 2 sides and the included angle measure that they make. All right, if you have that, then it's going to be equal to 1/2 times the product of the 2 sides, so times 3 times 7 times the sine of the angle measure that they make up. So times the sine of 20 degrees. All right, so that's going to be 21 over 2 times the sine of 20 degrees. So if you punch that in the calculator, you can just punch that in all in a row. 21 divided by 2. Well, I don't know if I'd put that in all in a row. I'd probably say 21 divided by 2, and then say that answer times the sine of 20 degrees. All right, and they want to round to 2 places. And I got 3.591, so 3.59 is my answer. Again, make sure your calculator's in degrees. Now this next problem, I want to find the area. This is a side-side-side triangle. So this is where we have to use Heron's formula. That's 1/2. First we have to find S, which is 1/2 times A plus B plus C. And then Heron's formula, the area is equal to the square root of S times S minus A times S minus B times S minus C. All right, we're definitely going to get a decimal here. If I add up 11, 11, and 9, that's going to be 31. So 1/2 times 31 is going to just give me 31 over 2, which as a decimal is 15.5. For me, it's easier to deal with decimals here. All right, so this is going to be the square root of 15.5 times 15.5 minus 11 times 15.5 minus 9 times 15.5 minus 11. All right, and for me, I'll show you again. I like to do decimals because then I can just say that's the square root of 15.5 times Usually I can do this in my head. You can use your calculator if you want. But 15 minus 11 is 4, so that's 4.5. And then 15 minus 9 is 6, so that's 6.5. Then again, 15 minus 11 is 4.5. All right, so now I'm going to say the square root of 15.5 times 4.5 times 6.5 times 4.5. All right, and I got, if I round this to two places, this is 168, so that'll be 17. And that's square units, of course. All area is going to be square units, but it doesn't matter. It doesn't have the units down there. All right, problem number 9 is a trig equation. So we need to solve for cosine of theta. So first, to solve for cosine of theta, you need to subtract 3 from both sides. So then I'll have 2 cosine theta equals, you got 2 minus 3, or negative 1. Divide both sides by 2. So cosine of theta equals negative 1/2. So we're looking for the two places where cosine of theta is negative 1/2. So I like to bring up the Salty Sea chart to remind me where cosine is negative. So I want the answer from the second quadrant and from the third quadrant. So all I need to do is name the angle measure from the first quadrant, where cosine would be positive 1/2, and that's pi over 3. As if you look at the points in the first quadrant on your unit circle, the only one that has a positive 1/2 in the x coordinate is pi over 3. So you can either use your big unit circle to find these other two answers, or just use the reference angle chart, or the reference angle formula. It's going to be pi minus pi over 3 and pi plus pi over 3. That's going to be your two answers. All right. And again, if you look at your unit circle, you'll see that at 2 pi over 3, there's an x coordinate of negative 1/2. And at 4 pi over 3, there's also an x coordinate of negative 1/2. So that's your two answers. 2 pi over 3, 4 pi over 3. Now in the next problem, we want to first get the sine squared by itself. So this is going to be, I have to divide by 4 on both sides, and I'll have sine squared theta equals 1/4. Take the square root of both sides. So I have sine theta equals, remember I have to put a plus or minus in front. And then the square root of 1 is 1 over the square root of 4 is 2. So I want all the places where sine is equal to positive 1/2 and negative 1/2. So that means I want an answer from each quadrant. So I have 4 answers, right? Because sine is positive in 2 quadrants and negative in 2 quadrants. All right, you should know by now that the sine of pi over 3 is equal to pi over 6, sorry. Whew. Pi over 6, the sine of pi over 6 is equal to positive 1/2. So then to get the answers in the other quadrants, I can say pi minus pi over 6, pi plus pi over 6, and 2 pi minus pi over 6. So in the second quadrant, that's going to be 5 pi over 6 when you subtract. In the third quadrant, when you add, that's going to be 7 pi over 6. And in the fourth quadrant, when you subtract, that's 11 pi over 6. So your 4 answers are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, so it's this one right here. The next problem is a sum or difference problem. It says express the sum or difference as a product of sines and or cosines. So we need to look at our formula sheet. So we have a difference and we want to change it to a product. Cosine alpha minus cosine beta is the last sum to product formula we have down there. So our alpha is 10 theta and our beta is 4 theta. And we follow the formula. Notice the formula has a negative 2 in front. It's the only one that has a negative 2 in front. So it's negative 2 times the sine of alpha plus beta divided by 2. So that's going to be 10 theta plus 4 theta, or 14 theta divided by 2, times the sine of alpha minus beta divided by 2. So 10 theta minus 4 theta, that's going to be 6 theta divided by 2. All right, so that's going to be equal to negative 2 sine of 7 theta times the sine of 3 theta when you divide by 2. All right, and so you can see that that's got to be this answer right here, B. All right, now 12 and 13. 12 and 13 are going to be problems where we use X, Y, and R. So we start with what's on the inside, and we'll say the cosine of theta is equal to negative 1/2, which is equal to X over R. Now, which quadrant is inverse cosine negative? Remember, inverse cosine is defined between 0 and pi. So that means theta is in the second quadrant. That's important because that tells us that the y's are positive and the x's are negative. So x is going to be negative 1 and r is going to be positive 2, and we want to find the tangent. So remember, tangent is y divided by x. So we have the x, we have the r, we just don't have the y. So I need to find the y using the formula x squared plus y squared equals r squared. We know that x is negative 1, so that's negative 1 squared plus y squared equals, we know r is 2, so that's 2 squared. So 1 plus y squared equals 4. So y squared is going to be equal to 3. So I take the square root of both sides, and y equals, usually I would put plus or minus, but since I know I'm in the second quadrant, the y is positive, right? So it's going to be positive square root of 3. So now let's write what tangent is equal to. So tangent is y over x. Y is positive square root of 3. X is negative 1. So positive square root of 3 divided by negative 1 is going to be negative square root of 3. So that's my answer. All right. We're going to do the same thing on problem number 13. So the inverse being on the inside there, that means that the sine of some angle measure is equal to 1/2. Now sine is equal to y over r. So y is positive 1 and r is positive 2. Since we're taking the inverse sine of a positive number, remember inverse sine is defined between pi over 2 and negative pi over 2. So if it's the inverse of a positive, we know we're here in the first quadrant. All x's are positive in the first quadrant. All y's are positive in the first quadrant. We want to find the cosine of whatever angle measure that is in the first quadrant. Cosine of theta is equal to x over r. So we have y, we have r, we need x. So we use the same formula. x squared plus y squared equals r squared. So x squared plus 1 squared equals 2 squared. All right, so I'll get x squared plus 1 equals 4. So x squared equals 3. Take the square root of both sides. And I would normally put a plus or minus, but since I know it's in the first quadrant, the x has to be positive. So x is equal to positive square root of 3. So now I can find what the cosine of theta would be equal to. Positive square root of 3 over the r, which is 2. So square root of 3 over 2. That's my answer. All right, for number 14, anytime we're trying to take the inverse of 0 or 1 for sine or cosine, I would always use the unit circle. Because remember, then it's going to have to be a quadrantal angle. So this is 0 radians, pi over 2 radians, pi radians, and 3 pi over 2 radians, and this is back to 2 pi. So if you look at those 4 points, there's only one of them where the y is going to equal 0, where inverse sine is defined. Because inverse sine is going to be defined between negative pi over 2 and negative pi over 2. So there's only going to be one point that's going to have a y of 0. So this point right here is the point 1, 0. This point up here is the point 0, 1. And this point down here for 3 pi over 2 or negative pi over 2 is 0, negative 1. So the only one that has a y of 0 is 0. So the answer to that is 0. So that's the only one where inverse sine is defined. If it was a trig equation, it would be different. If it was a trig equation, the answer would be 0 and pi. But since it's an inverse equation, we just take the answer where inverse sine is defined. All right. So now this says graph the function y equals 2 sine of 4x. Now, the bigger the number in front of the x, the more periods you're going to have, the more times you're going to be crossing the x-axis. So I can go ahead and tell you it's not going to be A or D. It's going to be one of these two. All right, and I know that because the bigger the number in front of the x, the smaller the period, so the more graphs you're going to have. We just have to figure out which one it is. So the amplitude, that just makes it go up a little faster. So the amplitude here is 2. The period, if you remember for tangent, the period is pi divided by omega, so it's pi over 4. Then we have to figure out two things for tangent. We have to figure out where does it cross and where is it undefined. Because where it crosses is going to be where it crosses on the graph. And then where it's undefined is going to be where you would have your vertical asymptotes. Even though the graphs don't show the vertical asymptotes, it would be important to figure that out. So we know that the tangent of 0, when x equals 0, that's going to be tangent of 0. It always crosses at 0. So if I add the period to that, I'll get other places where it crosses. So it's going to cross at 0, pi over 4. If you add pi over 4 again, that would be pi over 2. If you add pi over 4 again, that's going to be 3 pi over 4. So it's going to keep crossing at multiples of pi over 4. Now, where is it undefined? Well, we know that if that was just tangent of x, its undefined first place is pi over 2. But that's not just x, that's 4x. So if I divide both sides by 4, I'll have x equals pi over 8. So that's where the vertical asymptote is going to be pi over 8 And then if you add pi over 4 to that or subtract pi over 4 from that, you'll get other places. So that's going to be pi over 8, 3 pi over 8, and so on and so forth. Now really, if we just match up the places, since this is a matching test, or a multiple choice test, we just want to make sure that it crosses at 0, pi over 4, pi over 2, places like that. So let's see, this would be 0, this would be pi over 4 because that's between 0 and pi over 2, and then pi over 2, and then 3 pi over 4. So if you look at this one, it crosses at 0 and it crosses at pi over 2, but it doesn't cross at pi over 4. So it can't be C, so that just leaves you with B. So again, remember, the bigger the number in front of the X, the more graphs you're going to have in that standard window because your period is smaller. All right, on problem number 16, we're asked to graph y equals 2 secant of 1/3 x. Before we can graph that, though, we usually have to graph its reciprocal, cosine. So we want to graph y equals 2 cosine 1/3 x. And then we'll use the places it crosses and the high points and low points to get our U-shaped graphs and our asymptotes. So the amplitude here is 2. The period is 2 pi divided by omega. Omega is 1/3. So if I flip and multiply, what's my period going to be? 2 pi times 3. It's going to be 6 pi. So what does that mean? Well, this isn't a phase shift or anything, so we know that we're going to be starting at 0 and we're going to end at 6 pi for one complete period. So I need to get my 4 subintervals. All right, so I start at 0, I end at 6 pi. All right, now I need to figure out what do I add each time. Well, you take the period and you divide by 4, since there's 4 subintervals. So that's 3 pi over 2. We need to add 3 pi over 2 to a significant point to get the next significant point. So 0 plus 3 pi over 2 is 3 pi over 2. And then 3 pi over 2 plus 3 pi over 2 is 6 pi over 2. 6 pi over 2 is 3 pi. Again, remember that's 6 pi over 2 because we have to add 3 pi over 2 to that again. That would give us 9 pi over 2. And then here's where we can check and make sure we've been adding the fractions right. So that better be 9 pi over 2 plus 3 pi over 2. And it is, because that's 12 pi over 2, which is the same as 6 pi. All right, so if I graph cosine, let's see, here's 0. Let me put it, well, I'll put it in this color, and then I'll do secant in the other color. 3 pi over 2 is going to be in between, this is pi right here, because that's pi, 2 pi, 3 pi, 4 pi. 3 pi over 2 is between pi and 2 pi. All right, so that's going to be another significant point. And I really don't have to put a point there. I'm just wanting to mark these off and say, okay, that's 3 pi over 2. And then 3 pi is right here. And then 9 pi over 2 is between 4 pi and 5 pi. So right there, that's going to be 5 pi over 2. And then there's 6 pi. All right, so we just need to graph cosine like it would normally look. So cosine usually starts at a high point. So its high point is 2. So it's going to start here. Then at the next significant point, it's going to cross. At the next significant point, it's going to have a low point of -2, which happens to be where I drew 3 pi, but I'm just going to put the point there on there. And then at the last significant point, it's going to end at at the next significant point, it's going to cross. And at the last significant point, it's going to end at a high point. So it's going to look something like this. All right. So we want to use that graph to help us graph the secant graph. So anywhere that I have a high point, I draw a U-shaped graph opening upward. Anywhere that I cross, I have a vertical asymptote. Anywhere I have a low point, I draw a U-shaped graph opening downward. Again, I cross right there, so there's a vertical asymptote. Then I have a high point right here, so it's a U-shaped graph opening upward. So we know that we have 1 on the axis right here. So A and B both have 1 on the axis, but C and D do not. So you know that it can't be one of those. Now we need to have a U-shaped graph opening downward at 3 pi. So right here at 3 pi, a U-shaped graph opening downward. But over here at 3 pi, there's no U-shaped graph opening downward. So it has to be A. All right. All right, so the next problem, these next two, they're gimme problems. Don't miss these. Number 17, find the period of y equals cosine 3x. Remember, period is 2 pi divided by omega. So the period is 2 pi divided by 3, or 2/3 pi. Number 18, it's -4 sine 1/3 x. Find the amplitude. The amplitude is the absolute value of the number in front of the trig function. The absolute value of -4 is 4. So the amplitude is 4. All right. Now, number 19, this is a half-angle problem, so we have to make sure we have the right formula down. The formula is plus or minus the square root of 1 minus cosine theta all over 2. So you get that from your formula sheet. Now, first we need to know where is theta over 2 located. So if theta is between 0 and pi over 2, theta over 2 is going to be between 0 and pi over 4. The reason why that's important is because you want to know where the theta over 2 is located, so you'll know whether to put a plus or minus in front. So theta is in the first quadrant. All the trig functions are positive in the first quadrant. So I know my answer here is going to be positive. Okay, so the sine of theta over 2 is going to be positive. I normally wouldn't put a plus sign for positive, but I'll put it there just to put it there. Now, what else do we need? We need cosine theta. We don't know what cosine theta is equal to, so we have to figure it out. We know we're in the first quadrant, so all the x's and y's are positive. I'm also given that sine of theta is 1/4, and remember that's y over r. So if I have y and r, I can figure out x. So I say x squared plus y squared, that's going to be 1 squared, equals r squared, which is 4 squared. So I get x squared plus 1 equals 16. Or x squared equals 15. Take the square root of both sides. I'm in the first quadrant, so I know that x is going to be equal to the square root of 15. So now I can figure out what cosine theta is equal to. Cosine theta, remember, is x over r, so it's going to be the square root of 15 over r, which was 4. So now I'm going to follow my formula and say 1 minus the square root of 15 over 4 all over 2. So all I did was I took my formula and I plugged in the square root of 15 over 4 for cosine theta. Now, I need to rationalize this. Remember, I want to multiply the numerator and denominator by a number that would get rid of the 4 and make the denominator something that I can take the square root of. That number is going to be 8. 8 will get rid of the 4 because 8 divided by 4 is 2. And the bottom would become the square root of 16. And we can take the square root of 16. So I do have to multiply the 8 times both numbers there. So that's going to be a positive and its square root of 8 minus, again, 8 times this term. 8 divided by 4 is 2. So that's going to be 2 square roots of 15 over the square root of 16, which is equal to 4. So that's my answer. So it's C. All right, for the next problem, I want to know what the sine of 2 theta is. So I need to look at my double angle formulas. And if you look at your double angle formulas, you can see that sine of 2 theta just has one formula. It's equal to 2 sine theta times cosine theta. In this problem, we were given what cosine theta equals to, and we were given where theta is located. So theta is located between 3 pi over 2 and 2 pi, so theta is in the fourth quadrant. That's important because in the fourth quadrant, y's are negative and x's are positive. And if I need sine and cosine, and I have cosine, I have to solve for sine. And remember, sine is y over r. So when I find the y, I need to make it negative. So cosine is x over r, so I want to use these values and solve for y. So that's going to be x squared plus y squared equals r squared, or 5 squared plus y squared equals 13 squared, or 25 plus y squared equals 169. All right. Or y squared equals 144. Take the square root of both sides. Again, remember we're in the fourth quadrant, so y is going to be equal to a negative 12, not a positive 12. So now I can figure out what sine of theta is equal to. Sine of theta is going to be negative 12 over, what was r? 13, right? So it's negative 12 over 13. That's important because I got to plug it in right there in my formula. So I'm going to plug in, this is going to be 2 times negative 12 over 13 times cosine theta is 5 over 13. All right, so just multiply. Think about that like it's 2 over 1 and multiply straight across. Whenever you multiply straight across, you're going to get negative 120 over 13 times 13 is 169. So negative 120 over 169 is the answer. All right. The next problem, number 21, really just has too much information, if you look at it, because you want to find the secant of theta, and it gives you what sine and cosine is equal to. Well, remember, secant is the reciprocal of cosine. So all you have to do is take the answer it gives you for cosine and flip the answer. That'll be 4 over the square root of 15, which then you need to rationalize. So the answer is 4 square roots of 15 over 15. Again, it's just the reciprocal of cosine. 4 square roots of 15 over 15. All right, the next one. Oh man, this is a toughie here. Convert the angle in radians to degrees. So there's two ways to do that. Either you plug in 180 for pi, or you multiply by 180 over pi. Either way, it's going to be 180 over 5. So 180 divided by 5. That's going to be 36 degrees. You can do that in your calculator. Number 23, use the fact that the trig functions are periodic to find the exact value of the expression. Do not use a calculator. What that means is, and I'm going to write it over here to the side, remember if angle measures are bigger than 360, we subtract 360 from them as many times as we need to until we get a value between 0 and 360. So if I subtract 360 there, that's going to give me the sine of 405 degrees. That's still bigger than 360. So I subtract 360 again. That's going to give me the sine of 45 degrees. So what that means is the sine of 45 degrees lies in the same position as the sine of 765 degrees. So the point for 45 degrees, or pi over 4, is square root of 2 over 2, square root of 2 over 2. So the y-coordinate is square root of 2 over 2. So that means the answer is just square root of 2 over 2. All right, the next problem. Find the exact value. Do not use a calculator. If you don't get these, I feel really, really, really bad, like I did not teach you. So make sure that you get these right. These are gimmies. All right, so the tangent of 2 pi. Usually I don't remember the values for 2 pi. So if I was finding the tangent of 2 pi, I would subtract 2 pi from that, because that tells me that the tangent of 2 pi lies in the same place as the tangent of 0. And we all know the tangent of 0 equals 0 because that was the place where it crossed the x-axis, remember? Tangent of 0 equals 0. If you need to write down the unit circle to see that, remember it's going to be y over x, so that'll be 0 over 1, all right, which is 0. The sine of 0. If you think back to the graph of sine, remember how it crosses at the x-axis there? The x and the y-axis is where it starts. Well, the sine of 0 is also 0. If you need to draw the unit circle to figure that out, that's fine. It's you would look here at 0. That's the point 1, 0, and sine is the y-coordinate. All right, but hopefully you can remember that one. You got to remember those common angle measures. All right, so now we're getting into the law of sine and law of cosines problems. So I'll know that it's a law of sines problem if I have a corresponding side and angle that I know. So here on number 26, you see I know that this angle measure is 35 degrees, and the one across from it, that's 8, that's side B. So when you know a corresponding side and angle, that makes it a law of sines problem. So I'm going to say the sine of 35 degrees over 8, that is the ratio that I'm going to use to solve for side A and side C. Now I can figure out angle C really easy, right? Because all I have to do is say 180 degrees minus 120 degrees minus 35 degrees. So you can see that angle C is going to have to be equal to what? 25? Yeah, that's 25. All right, so there's angle C. Now let's solve for side A first. All right, so to solve for side A, I use this ratio here. I say it's equal to the sine of 120 degrees over A. Now you cross multiply and divide. So I'm going to have A times the sine of 135 degrees equals 8 times the sine of 120 degrees. Divide both sides by the sine of 35 degrees. and I have what side A is equal to. So I want to do that in my calculator. So I'm going to say, and I have to round to 2 places it looks like if you look at the answers. 8 times sine of 120 divided by sine of 35. And I get that side A is about 0.078, so 12.08. Now you can probably figure out the answer just by knowing what, like I don't actually have to solve for side C, because look at this. So side C equals 25 degrees. So this one says 20 degrees, so we know that one's wrong. This one says 30 degrees, so we know that one's wrong. And then side A is 12.08. This one has side A as 5.89. This one has side A as 12.08. So when we solve for side C, if you wanted to come up here and do that and use the 25 degrees and C and cross multiply and divide, you'll get 5.89. So just to save time, I'm showing you when you find 2, you got the answer there. It has to be A. Just make sure that you know what variable you solve for right here. All right. Now this one doesn't give you a triangle, so I'm going to have to draw a generic triangle over to the side. So that means everything's not going to be to scale. I'll say that, let's see, so angle B, let's just say this is A, B, and C. It doesn't matter. As long as this is side C, this is side B, and this is side A, because they go across from each other. So it tells us that angle B is 114 degrees. Side B is 3. Well, that right there tells me it's a law of sines problem, because I have an angle in its corresponding side. And then it tells me that side A is 25. Okay. So since I have side A, let's try to solve for angle A. So I'm going to start off with the angle measure that I know over the side that I know, the corresponding one. So that's equal to, now I'm going to use 25 and sine and A, so that's sine A over 25. So now let's cross multiply. So I get 25 times the sine of 114 degrees is equal to 3 times the sine of A. Divide both sides by 3. All right, so I get 25. I'll have to work out the left side. 25 times the sine of 114 divided by 3. So I have 7.61 equals the sine of A. So the way that you find this out is you do inverse. Right? We're going to have to say inverse sine of 7.61. Now some of you probably already know what the answer is, because you can't take the sine of an angle measure and get something bigger than 1. But if you plug that in your calculator, you do inverse sine of 7.61, it's going to give you an error. All right? Because you can't take the sine of an angle measure and get something bigger than 1 or smaller than -1. So there is no triangle. All right, no triangle will work out and with those values. So problem number 28 is a, let's see what we have. We have, that's 25 degrees, that's 9, that's 2. We don't know any corresponding side and angle. So it's going to be a law of cosines problem. All right, so since we know 2 of the sides and the included angle, we can solve for side B though. So we want to use the formula b² equals a squared plus c squared minus 2ac times the cosine of angle B. All right, so b squared equals 2 squared plus 9 squared minus 2 times 2 times 9 times the cosine of 25 degrees. Because if this is side B, this has to be angle B. All right. So we need to work all that out. And remember, we have to take the square root at the end. So 2 squared plus 9 squared, that's going to be 85. And that's going to be minus 2 times 2 times 9 is 36 times the cosine of 25 degrees. So this is probably where I would take the square root. I would just plug in all of that. I'd say the square root of, and then plug all that in. All right, and when you do that, remember we use cosine, not sine. It's all these are rounded to 2 places, so I get side B is about 7.24. So I would look down here, and any of them that doesn't have side B equals 7.24, I'd go ahead and mark out. So this one is 6.24, this one is 8.24, so we know it's not one of those. Okay? So the next thing that I would do was I would either solve for angle A or angle C. So I'm going to solve for angle A. Now remember, I showed you how to set up your formulas, your law of cosine formulas, so that you could solve for the angle. So it's cosine of angle A equals b squared plus c squared minus a squared over 2bc. All right, so this is equal to b squared is 7.24 squared plus c squared. C is 9, so plus 9 squared, minus a squared, so minus 2 squared, over 2 times 7.24 times 9. All right, so you want to work all of that out and then use inverse cosine. So I'm going to work everything out, and then I'm going to say the inverse cosine of whatever it gives me. So 7.24 squared plus 9 squared minus 2 squared divided by, and then I'm going to put all this in parentheses, 2 times 7.24 times 9. All right, so I got 0.993075506. So in my calculator, what I'm going to do is I'm going to hit second cosine, and then I can hit second, and the little minus symbol puts the last answer in for me. When I do that, that gives me that angle A, well, I'm not going to put equals there. I'm going to put angle A is about 6.74. They have A rounded to one place, so 6.7 degrees. So now come down here and see which one of these has A equals 6.7 degrees. That's this one. So B is wrong. So it must be when I solve for angle C, I get 148.3. If you want to do that just to check, you say 180 minus 25 minus 6.7, you'll get 148.3. All right. So number 29 looks like another law of sines problem. Law of cosines problem, because you don't have a corresponding side and angle. All right. So what we want to do is we first want to solve for side C. So C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of angle C. All right, and so we know the cosine of angle C is 115 degrees. So let's plug everything in. So side A is equal to 2, and side B is equal to 4. So that's going to be 2 squared, which is 4, plus 4 squared, which is 16, minus 2 times 2 times 4. 2 times 2 is 4 times 4 is 16, times the cosine of 115 degrees. All right, so that's 20 minus 16 times the cosine of 115 degrees. Now remember, that's what C squared equals to. So if we take that and take the square root of it, that'll be what C is equal to. So it's the square root of all of that. So I'm going to do that in my calculator. All right, and so I got, that's approximately, on around the 2 places, 5.17. So what I would do is I would come down here, and anywhere you don't have C equals 5.17, I would mark that answer out. So that means I would mark out answer D, and I would mark out answer A. Okay? So all we need to do now is solve for one of the angle measures. So let's just go ahead and solve for angle A, since that's what we solved for last time. So the cosine of angle A, we already have the formula written down. B squared plus C squared minus A squared all over 2BC. So that's going to be, B squared is, or B is 4, so that's 16 plus, I don't know what, I'm going to just leave this as 5.17 squared, and then minus A is 2, so A squared would be 4, all over 2BC. So 2 times 5.17 times, well, B was actually 4, so I can put in a 4 and then a 5.17. It wouldn't matter, but I want to match my formula. So, all right, so I'm going to do all that in my calculator and then do inverse cosine of whatever that is. So 16 plus 5.17 squared minus 4. I'm going to say divided by, and I'm going to put this in parentheses. That's going to be 2 times 4 times 5.17. All right, and I get 0.9400218545. So I'm going to say inverse cosine of my last answer. And I got, if I round this to one place, did I plug in everything right? I may have fat fingered something. Let me plug it in again. Yeah, I did something wrong. I'm sorry about that. I didn't see my answer down there, so that's how I know I messed up something. I got 0.936385397. So inverse cosine of my last answer. So I got 20, and if I run that to one place, it's just 20.5. So that's angle A. So see which one has A equals 20.5. This other one has B equals 20.5, so I know it's wrong. So the answer has to be C. Now, if you want to check and make sure, you could just say 180 minus 115 minus 20.5, and you should get 44.5 for angle B. All right. And the last problem. So this is a side triangle. So what we need to do is solve for two of the angle measures, and then we'll find the third one by just saying 180 minus the two that we found. So let's start off with cosine of A. All right, so because we already have that formula, so it's b squared plus c squared minus a squared all over 2bc. So if this is angle A, this is side A. If this is angle C, this is side C. If this is angle B, this is side B. All right, so it's going to be, let me just do some of this in my head. 5 squared is 25 plus 7 squared is 49 minus 6 squared is 36 over 2 times times 7. All right, so it looks like my denominator is going to be 70. My numerator is going to be 38. So that's what you want to take, and that can be reduced, but that's what you want to take the inverse cosine of. So this tells me that angle A is about, if I round it to one place, 57.1 degrees. So look down here, and any of these that don't have A equals 57.1 degrees, mark those out. All right, now let's solve for angle B. So cosine of angle B is going to be equal to A squared plus C squared minus B squared all over 2AC. All right, so that's going to be A squared is 36 plus 7 squared is 49 minus B squared is 25 over 2 times A times C. So 2 times 6 times 7. All right, so I'm going to plug that in my calculator. So I get 60 over 42 times 2 would be 84. And of course, that can be, 42 times 2, is that right? Yeah. That can be simplified, but you can just say 60 divided by 84 in your calculator. And say inverse cosine of the last answer. And I got angle B is approximately 44.4 degrees. So you can check the last angle measure if you want. You say 180 minus 44.4 minus 57.1, and you should get angle C is 78.5 degrees. And that finishes your review.